All right, Rob.
So,
Yeah, you today are going to be talking all about the Artemis program from the perspective of like the overall mission. I've tried to come in with a little bit of more background on the engines and the actual rocket itself.
yeah.
Overall, this is probably going to take more than just one podcast to discuss.
Oh, yeah.
So,
And that's kind of what I'm expecting with this. Like, I'm looking
Right.
at this from the 20,000, well, I guess, whatever.
from a high perspective,
Very high perspective.
remote sensing.
Yeah. So I'm taking it from that perspective because this is the first one, and I'm learning as we go through this too. Like, that's half of why we do this, is for us to learn.
Right.
So,
Exactly. Yep.
So I'm really trying to get my head around what is Artemis? What are we doing here? What, and how does it relate to what we've done in the past? Right. So, just to give an overview of where I'm coming at from this is, first of all, we got to look at where we started with spaceflight. Right. And I'm only going back to Mercury, right? The Mercury missions, back in the 60s, I don't think maybe late 50s, but it was a smaller capsule, right? And they were launching one human, and the eventual goal was to get that human into orbit. Okay. We could go through, you could have a whole podcast just on just the Mercury mission, right? But that was one human. Let's first get him up, then let's get him into orbit. Okay.
Right.
And of course there were some animals in there too and stuff like that. But so that was good. Russians beat us to it, but we did get there as well. And then you had the Gemini missions, right? So that was the Gemini twins. Gemini mission was 2 humans. We get them in orbit.
Really?
Yeah.
I didn't even realize that that's why it
You
was.
never made
named
that connection, did you?
No.
Yeah. I'm not. Yeah, that's why. I assume that's why. I don't know why it wouldn't be, but
Yeah, that's cool.
yeah. And so the twins, 2 people in orbit going. So not only are they getting in orbit, they wanted to see how long can humans really last up there? What kind of conditions can they endure? I guess you could say most importantly, or something that usually gets left out, is the rendezvous capabilities. I don't think, as lay people like us, we don't really understand how difficult it is to make 2 spacecraft dock.
There's a lot of space in space. Yeah, the distances to get that all to work out right, and
there's no real landmarks to take into account.
Right, and the energies it takes to be able to accomplish that.
Yeah.
Just like having the exact math back then, it was done, a lot of the hand calculations, some of it was done with computers, but as we talked about in our last podcast, the people who are the calculators who are actually behind the scenes. And of course, that's all done with computers these days.
Right.
But yeah, it's an amazing feat in almost every aspect of the original projects with Gemini. Yeah.
Yeah. So, and the idea that there's this confusion about, like, when you're in orbit, if you have 2 things in orbit and you want to catch up to one, do you speed up or do you actually slow down? And there's a whole non-intuitive aspect to orbital dynamics, which we're not going to get into. But so anyway, so Gemini is 2 humans in orbit. They learn how to dock, they learn how to rendezvous and how to actually make that work. And then you've got the Apollo missions. And that's when you have 3 humans in orbit. Really 3 humans to the moon's orbit. 2 of them land, 1 of them stays up, but the 2 land and explore. And that stopped with Apollo 17 back in like 72, I believe. That was it for the moon. Like, we have not been back to the moon with people since then. And that has always kind of been like, it's obvious, but it's not obvious, right? Like, we have technically the ability to send people there in a way, but we don't have the political will. Like, we don't have Russia trying to get there before us, so.
Right. The locus of our motivation has to be internal versus an external threat.
Right.
Yeah, the space race is certainly starting up again, though, as we discussed once again in our last podcast, was all about that, how the space race is in 2.0,
Yeah.
right? So yeah, Artemis is the new missions that we're going to be doing, and we're going back to the moon.
Yeah. Which is kind of amazing. And like we talked about before, like I wish in all the research that I do, when I read about the space missions, I think, man, how cool would it be to live in that time? And we are living in that time again. So, so after Apollo, then we started doing the space shuttle. We started doing the International Space Station. And now with the space shuttle's gone. We can't do anything with the space shuttle anymore. So we are using Soyuz capsules to bring people back from the space station. And we're using, I forget what kind of rockets to send them up back in the day. But now in just the past year, we've been able to do SpaceX Dragon capsules with astronauts.
I don't think we're using Soyuz anymore. I think that's pretty much been decided, given global geopolitical issues. I'm pretty sure that they don't want us, and we really don't want them anymore.
Yeah.
Which is unfortunate because the International Space Station is still operating.
Mm-hmm.
The Russians are still on the International Space Station. I think that their time there is probably going to be limited. I think that it's going to be short-lived, unfortunately.
Yeah, I don't think we can. I think that's a general prediction. I doubt we could really even figure out exactly what's going to happen. You just don't know.
Yeah.
But it's remained fairly insulated. The space station has remained fairly insulated from geopolitics on Earth.
Agreed. But the space station is planned to be deorbited.
Yes.
And that's part of this program. And I think let's just take a step back a second and, just kind of clear the air a little bit when it comes to the space shuttle and the space program. The decision to end the space shuttle program was kind of already in place prior to some of the issues that we had with both Challenger and Columbia, with the space program kind of planning to figure out how to get things into space and use what basically is a space pickup truck. They were trying to work on reusability.
Mm-hmm.
They're trying to drive down costs. They accomplished some of that. The cost part wasn't really done very well. And arguably the same thing can be said for Artemis. We'll talk about that. But, I think a lot of people think the space program is, broken. And in reality, it's just in transition. And this was a planned transition. It's not something that was just like not well thought out. We knew NASA planned on doing this. This was not something that was, we shut down the space program like a lot of people thought. We planned on ending the space program with the space shuttle. We already at that point knew we were going to be making this large rocket, which has turned into what now we're calling the SLS, which we'll be talking about in a little while. But there's a lot of people out there who think the space program was dead. And it's really a shame. I think the communication wasn't really the best. And I think that's because the direction, as we'll discuss, was not always really clear either.
Yeah. And there's a bit of, I think the communication has to be there too. But, when you retire something as iconic as a space shuttle, it's hard to say, oh, but we are doing some other things. You just can't see them yet.
Right.
So, I would say there has been a general feel of the space exploration is dead, but it's just sort of diverted in other areas. So
exactly.
And I think a lot of that has been the exploration using machines, using robots, which has been just amazing and great. But that's a whole nother thing.
And that's where a decent amount of the science is actually done. To be clear, is with the robots. And I think there's a place for all of the above.
Yes.
There are some out there who think that the robots are the only way to go and that this manned mission stuff or crewed mission stuff is not worth it. And others are saying, robots, they don't get the full taste of what space is and the human experience. And I get that too. And everywhere in between. But I think a mixture of both is necessary.
Yeah. You gotta put the pieces where they should go.
Right.
You know?
And place humans where they are safe and robots where it's not.
Yeah.
Yeah.
So now let's talk about Artemis. Okay. Do you want to put my
Yeah, sure.
screen up there? So Artemis, just actually quick note, just looking at the, I don't always take in a logo. But if you look at that, you got the blue Earth, you've got the red rocket going up to a gray moon, and it's all making that A for Artemis.
I didn't even see that.
Right?
That's really actually pretty cool.
It's pretty good. You don't think a lot goes into these logos, but they really do. Man, they take a lot of pains to make it look good.
Agreed. Yeah, that looks that's really neat now that you point that out.
So yeah, I thought that was pretty cool.
Do you know if that's going to be their patch or?
I would think if it all goes like what the Apollo missions did, well, Apollo didn't have a logo, I don't think. I would guess that would be a patch, but there would be a mission specific patch.
Okay. Yeah, you're right.
That would have the names and the Artemis 1, Artemis 2,
Right.
So I'm not sure. But anyway, that aside, let's talk about like what Artemis actually is. Let's take the many mile view of this. The eventuality here is to land people on Mars. That's the huge far off goal, right? The eventual human exploration of Mars. But in order to do that, we have to do the lunar stuff. We have to land humans on the moon, and we have to have a sustainable presence on the moon. Before we do that, we have to just land on the moon, right? And in order to do that, we have to be able to orbit around the moon on this new stuff with people. And before we do that, we have to orbit stuff around the moon before we actually put people in there, right? So it's again a very iterative process,
right?
Where we want to test something with just machines, test something with humans, but don't do everything. Make sure a bunch of that works, and just keep going and going.
You have a really good like little graphic here. We can pull that up.
Yeah, let me see if I can find that one there. Yeah. Why don't you pull that up in full screen there? So the Artemis one, I didn't get to take a huge look at this, but I would say start over here in the green, right? You've got 1, 2, 3, and 4 right here, coming off of Cape Canaveral down here. And so you lift off from Kennedy Space Center. Right around here, you are jettisoning, well, you're losing some of the stuff. The boosters, those little white things. I know you're
over the Atlantic for those of you listening just audio.
Yeah. So the SLS is a big orange tank with 2 white solid rocket boosters, or 1 on each side. So 2 rocket boosters. So you lose those, and then you keep orbiting around the Earth, and then by the time you get here to 6, it's called translunar injection. Okay, so they're probably going to be in orbit a couple times, would be my assumption. They just simplified it as 1 for this graphic.
Sure, yeah.
But once you're in orbit, everything's stabilized, you're feeling good, kind of a rest stop, parking orbit. Then you start burning some of that fuel and going toward the moon.
And this is specifically for Artemis 1, just so we're clear. Artemis 1 is an uncrewed mission.
Yes.
So this is what's going to be happening. And I guess at this point, this is scheduled to be sometime this coming summer 2022, if it stays on schedule. There were some issues that I know that they were having with fuel line, I believe. So there was potentially some delay, but I think that they've got it figured out, and I'm thinking we'll probably see a launch this summer.
I think so too. Yeah. But yeah, so Artemis 1, 2, and 3 is what they have. Artemis 1 is uncrewed. Artemis 2 will be crewed but not land. And then Artemis 3 will be landing and exploring.
They'll just orbit the moon.
Yeah.
In Artemis 2.
Artemis 2 will be like Apollo 8. Remember where Apollo 8 launched, and they orbited the moon, did a couple orbits, figured out what they needed to do. Oh, actually, I think the lander and the command module separated.
Oh, really? Okay.
I think, if my memory is correct, they separated, and then they got back together. They did not land, but they did.
Sure, but
separate
you
and come
definitely
back.
want to practice that process
Mhm.
of the docking and undocking of your spacecraft in lunar orbit for sure.
Yeah. Yeah.
Yep. It's a proof of concept for sure.
Mm-hmm.
The one thing I will say that we have that they did not have during the Apollo missions is the ability to communicate from the far side of the moon, which is so
Oh,
helpful.
we can do that.
Well,
Oh,
I
do we
mean,
have satellites up there?
we've
that are
got satellites.
rebounding it. Well, yeah.
We've got satellites up there. There's all sorts of stuff. And if they don't have them, the ones that they have, they're going to put them there for sure. They're not going to have a blackout if they can help it.
Yeah.
Yeah, no way. That's just too dangerous.
Mm-hmm.
So, that's a big step forward. One thing I want to mention here is that Apollo, from a mythology standpoint, is the twin brother of Artemis,
Yes.
his twin sister. So this was not something that was also just by chance.
Mm-hmm.
The point of choosing specifically the sister of Apollo is that the next person that will be stepping foot on the moon's surface will be a woman of color.
Mm-hmm.
And so this is certainly symbolic, given that not a single woman or a single person of color has ever stepped foot on the moon.
Yes.
And I think that's a very thoughtful step that NASA is making a high priority and even naming the mission to represent that important step.
Yep.
So that's what Artemis is the twin sister of Apollo.
I like the way that they do put a lot of thought into the logos and the naming, and it's not going to be perfect because you don't have a perfect myth anywhere that matches, but I think it's pretty good.
So just looking here, it says mission durations, and it says 26 to 42 days. That's way longer than a normal mission would be. So my guess is that there's going to be a possibility of a lot of extra stuff that we are going to be able to test while it's up there.
Mm-hmm.
And a lot of that, once again, that we could not have done as easily during the Apollo era can now just be done with a remote, signal. We send the instructions, the computers do everything.
A lot more adjustment on the fly.
Because let's be clear, a lot of the things that are going to be done are still going to be those automated processes when the astronauts are on board.
Mm-hmm.
It's not going to be done by them. So as long as it works here, it should work then.
Yeah. Yeah. So then continuing on in this, they're going to get to the moon around around the orbit that they need to go to.
Like outbound transit 8 to 14 days. Look, that's a big window. It usually take only 3 days to get there.
It was only 3 days with Apollo.
I think you're going to see it parked in Earth orbit for a while. They're going to make sure they go through all the systems checks. It's going to sit there in orbit, and then finally, once they're completely satisfied, everything's functioning, they'll do that translunar injection.
Yeah.
But I think it's going to sit up there for a few days.
Yeah.
Which isn't uncommon.
No, and it's good to get those tests out of the way.
Especially if there's no people on board, you don't have to care. There's just no reason to rush things.
Exactly. Yeah. So then it looks like, and of course, there's far more stuff that's going on here, but I know that they're going to basically insert into a distant retrograde orbit. Honestly, I don't know what that is, but
I was just about to ask, what?
That'll be next time. Yeah, why are we using that orbit? But I think they're basically going to spend a lot of time in orbit. They're going to be doing a lot of tests. I think they're sending some mini satellites.
I did see that they have potential to bring along Cubesats.
Mm-hmm. Yeah, so they're going to launch some of those and just hang out, see it from afar, like kind of drive by, like as if you're, just driving by the national parks, you're just driving through with your car.
I have a hunch
Mm-hmm.
that some of the reason for having Cubesats, for those of you who don't know what a Cubesat is, it's a very small satellite that
about the size of could be about the size of a bag of bread.
I think they are starting to make them in different sizes, because I was looking up deeper on this, and they were explaining the exact design specs of a particular CubeSat size.
Okay.
So I think, and this is just a hunch, that they're going to be using this potentially as a way to engage the public. Yep. So that there's because the buy-in of the public is how these things get funded.
Indeed. Yes.
And if you can get the public's interest now and say, oh, there's a school group that has a CubeSat and from, this classroom and, from this elementary school, it just humanizes the experience and really brings it into our everyday lives, hopefully. So I think you're going to see some of that. And I think the CubeSat idea is a very strategic and smart idea.
I agree. And the more you get the public interested, the better it's going to be. And if anyone listening, like, you'd be surprised, when they put these things out there, like somebody said, you can do a cube satellite. I'm like, no, there's no way I'm doing a cube satellite. But if you pull some resources, you'd be surprised what you can get, like how you can cooperate with NASA and do cool stuff.
Right. And if you're going to be bringing things home, you need extra storage capacity. So just like any good cargo mission, either Earth or space, you never want an empty truck. You always want to drive with a full load, because otherwise, why did you waste that space? So they're going to fill it up with CubeSats. They're going to get rid of the CubeSats in orbit or wherever. And then now they can use that for whatever purpose they want to bring things back. Maybe it's lunar samples again, or, whatever. Maybe it's scientific experiments. Maybe it's trash. Who knows?
Yep.
But they're going to have that empty space that they'll be able to utilize.
Yeah. In fact, from the briefing, I don't know what it's called, but basically a press release about this I read today. This says this mission will also deploy 13 CubeSats to conduct new scientific investigations and new technology demonstrations that will improve our knowledge of the deep space environment, while engaging a broader set of universities, international partners, and private companies in lunar exploration than ever before on a single mission.
Nice.
So they're getting people to buy in. The other really important thing, so they're going to put stuff out there, learn stuff, get ready, and then they're going to re-enter. So they're going to come back to Earth, and one of the things that they read here is that the re-entry is a top mission priority because they need to test that heat shield.
Okay.
You can test it so much when you're on the ground, but you really got to test it coming back. Right.
Yeah.
They said, let's see.
Wasn't that? I guess it was tested during that initial launch that they did, but it only was in Earth orbit. Because there was a launch already of that SLS rocket. I think it was
just a splashdown.
I think they didn't have the extra velocity that they would be having from coming back from the moon.
It did not get toasty. I'm pretty sure it did not get toasty.
Yeah, but I think it just had normal entry type stuff, but not the extra speed it would have from the moon.
Right. Yes.
Right.
Yeah, they're talking, I think it would get re-entry at Mach 32, 24,500 miles per hour. So, yeah, I think that was more to test the parachutes.
Yes,
and
there was some of that for sure. Yeah.
But yeah, it's looking like it's going to splash down in the Pacific because that's the biggest one.
Right.
Bigger target, the better. And yeah, they're going to have just engineering equipment in there, and they will have life support systems on there, make sure that they actually work. But yeah, so that's Artemis 1, right? I'm not going to go deep in Artemis 2 or 3, but basically the idea to go from here is that Artemis 2 is going to be, again, that Apollo 8. You go around with the humans. You get those 4 people on there, and you're looking at making sure everything else works there. And then Artemis 3 is going to be the culmination of all of this, right?
Do we have any graphics for Artemis 2 or Artemis
I do not have any graphics for Artemis 2.
Keep in mind, I can edit this, so we're going to up, but that was a pretty cool freaking graphic.
Right?
Let's run that back, man. That was pretty cool.
I'll refresh that.
I love that.
Yeah.
And is that how you knew that it was what it was?
No, I read it in the press release thing that I read, which anybody can find. Actually, if I show this to you, Artemis Plan. This was back from 2020, Lunar Exploration Program Overview. So yeah, it is almost 2 years old, but we're looking at it from far enough away that the details aren't that important. But you can just find that on NASA. So let's see.
We can try to put some links in the description for things too.
I do want to mention the gateway before we stop. But,
Oh, there we go. There's like a
oh yeah, mission patches. There you go. So Artemis 1. Interesting.
no one gets to wear the patch though because no one went on the mission. It's the
Oh yeah.
I guess the people who operate the mission also get a patch.
Yeah. Yeah. Yeah.
Oh,
So,
okay.
yeah, so there's Artemis too. Obviously a little less detailed, but it looks like they have a lot more detail in the orbit before they leave, right? Because they got to make sure everything's working in tip top shape. And then they're going around. Now it looks like it's only one orbit.
Yeah. That's what it looks like, yeah.
That's what it looks like, but I would think they would be in there for a longer period of time, don't you think?
Well, it says that's number 11 on the thing there. So what is 11?
Lunar
say?
flyby just gives you the mean lunar far side altitude. Yeah,
It looks like
Maybe.
1 minute, one loop. And it says
Maybe.
4 days. 4 days outbound transit along free return trajectory. Yeah.
yeah. That's surprising, actually.
Yeah.
I would think they would have orbited the moon a couple times.
I think
'Cause
they
that's what
want
they're going to have to do.
I think they want to get out there and make sure they get them back quick.
Yeah. Okay.
I think it's a photo op.
That's fair. You do have to have your photo ops too. Let's see if they have something for Artemis 3 now.
Oh. There's a lot going on here.
Yeah.
This is not from NASA.
That's from ESA.
Oh, it's from ESA.
So
Oh, that's good enough.
Just as good. Yeah, yeah. So low Earth orbit, outbound coasting, and then outbound powered lunar flyby. Gateway. Gateway's going to be up by this point.
That's awesome.
Yeah.
Artemis 3 by, what did it say? What's the time frame?
2030.
Yeah.
That's coming up.
That's
coming
up.
Yeah. It's definitely coming up. Yeah. So, yeah, the other thing that we need to mention here is Gateway, right? So, Gateway is going to be this thing that orbits the moon that is going to be our gateway to the moon. Like, that's kind of what. So, not mythical, but it very, very, very direct, just like, a black hole is a hole in space that's very black. But
Yes.
so the thing that they're trying to do first, they've got two parts here. One is the propulsion. There's a fancy term for it, but they need a way to move it from Earth orbit to moon orbit. And so they've got the propulsion, and then they have the habitat portion of that. And that's the other thing that I think this is really hinging upon. That Artemis 3, if we're going to get there by 2030, this has to be there and ready to go.
Yeah.
The point being, it's sort of like the command service module that in the Apollo missions was orbiting the moon and had Michael Collins or other astronauts in there maintaining that. That's what this is going to be, but on a much bigger scale, be able to hold many more astronauts,
Right.
and do way more.
I mean, it's effectively a small space station.
Yeah.
But it's orbiting the moon instead of Earth.
Yeah.
Yeah. So it also, from my understanding, will have a universal docking system
Yes.
that will integrate across multiple different space launch platforms from multiple different countries.
Mhm.
So it is an international
Yes.
process. This is ESA versus, ESA and NASA working together. And I believe there's other private and other, governmental, other governments that are also involved in this too.
Yeah.
So the fact that they're trying to bring on commercial spaceflight, though, I think is notable.
Mm-hmm.
Part of the lander system is going to be likely SpaceX and or Blue Origin. It was going to be just SpaceX, and then, of course, Blue
Stuff
Origin
happened.
Blue Origin sued to have the opportunity to be involved as well.
Yeah. But yeah, I mean, so basically, first looking at Artemis and really looking at this, we're looking at uncrewed for Artemis 1, get out there with the machines. We're looking at crewed but just going around the moon, not even actually a full orbit, but looping around the moon, coming back for Artemis 2 with humans. And then we're going to take our 4 humans on Artemis 3, get them into the gateway, which should be built, and then get them down to the moon and explore. And then
is getting them down
the solar
to the
system is ours.
I think getting them down to the moon though is beyond Artemis 3.
I don't think so. Hold on. This time, so here it's saying this time to make history with the first woman and next man to walk on its surface. For long term, it's going to be the staging point. Oh,
First human to return to the moon will be on Artemis 3, it says.
Yeah.
You're right.
Yeah.
Cool.
There we go. Now, yeah, it looks like the human landing system, I think that's a kind of a separate thing too.
I think
attached to the.
I think that NASA has selected Blue Origin as their way to get to the surface, it says. But I have also seen that changed.
Yeah.
So is this the 2020 document?
Yes.
Yeah, things have changed.
Yeah.
So I know that SpaceX was chosen as a lander too.
Right.
Or over them. So yeah, SpaceX Starship will be a fully reusable launch and landing system to travel to the moon, Mars, and other destinations.
So yeah, I mean things are still in flux, and that's the nature of this.
But that's good. That means there's still competition. It's not just a decision. Like, and there's
True.
there's some competition. And I people give SpaceX, people give Blue Origin a, bad rap here on this for suing, and I get that. But the importance of having competition is very important in this process for the sake of having multiple potential options, as this is still unclear.
Yeah.
So I'm excited that they are going to have multiple options available to them, and Gateway allows that.
True.
Gateway allows that, and it could be all of the above and still function.
Yeah.
And they could be competing on price. They could be competing on reliability. They could be competing on so many different levels. And, if there's an issue with one of them, they can work together because there's integration already kind of involved.
Yeah.
So I think this is super, super important that we have this kind of forethought and planning. It's almost like the USB of, space, where you have this universal docking system. Like we have a universal serial bus. We have these USB drives that, everybody but Apple has to work with. Unless you live in,
almost universal.
Unless you live in Europe, where they're now making Apple be required to use USB-C, and that's kind of what we're talking about here, though. Like, we're requiring that these companies use a universal docking system because that's what the smart thing is to do. So you can actually dock. How horrible would it be to have people that are at risk and need help and you can't pick them up? Yeah. The fact that you have a docking system allows for that.
Right. I do like when you're talking about that competition, it reminded me of what is attributed to John Glenn, and I pulled it up here because somebody was asking him, how did you feel? How did you feel when you were in that rocket? He said, well, I felt exactly how you would feel if you were getting ready to launch and knew you were sitting on top of 2 million parts, all built by the lowest bidder on a government contract. Yep. So I don't fall into the camp of firmly you got to have competition and only competition, private company, or it's just a government contract. Like I don't know. That is above my pay grade, but I do know there are advantages to some of the systems and disadvantages to some of those systems. Sometimes I worry, like if you go back, this is a bit of a rabbit trail, but if you go back to Challenger and how the management of NASA and them cutting corners in the testing and the verification of systems and such, like that was one of the reasons that it blew up, was because it had to do with the temperature, and somehow for some reason it was basically like, it'll be fine. It's like
it was more of a frequency of launch kind of concern. We need to keep these things going up, and they weren't even close to hitting what they expected to be for like launch window opportunities. They weren't taking many of them, and so the frequency that they had claimed they were going to be able to achieve when the turnaround time with the space shuttle
Yeah.
was nowhere near what actually happened. And so, yeah, corners were cut.
And so are they cut less with a private company, or are they cut more with a private company? I don't know. I bet it depends on the company and the humans running that company. And I think something that we forget is that even though it's a spaceship, we're sending people out there, we're sending astronauts, flight pilots, we're still humans. We're still humans making human decisions. You still have leaders at the top that are making the best human decision that they can't, hopefully the best human decision, but we're still humans. It's not an automatic, you have to do it this way versus this way.
Right.
Anyway,
let's talk a little bit about the spacecraft itself. If we can get some images up of the different types of SLS rockets. So yeah, the Space Launch System, the SLS rocket, is actually multiple different types of rocket, all starting with the SLS that most people are thinking of when you're thinking of like the one for Artemis 1.
Oh, it's blocks. I remember in the Apollo missions and stuff, they would talk about block 1, block 2.
Yeah, so we've got a number of different types of SLS rocket. We've got the SLS Block 1 Crew, and that's going to be the initial one that's going to be used for our first Artemis mission, Artemis 1, and also for Artemis 2. And then this one, we're seeing the lower maximum thrust value, but it's still 15% higher than was with the Saturn V.
Okay.
So it's still a more powerful rocket, even in this configuration, than the Saturn V one that was used for Apollo.
Okay.
The second one there that you see, the SLS Block 1 Cargo, is just like its name implies. Everything else is the same except for the top part, which is where the people would have normally been, has now been replaced by a fairing. And that fairing is going to be able to carry just the hardware that we want to launch. And the discussion here is that not only is this going to be used for moon missions, lunar missions, but this would be capable, with the amount of thrust that it provides, to be able to launch something like direct to Jupiter, direct to Mars. And we wouldn't have to do these long roundabout trips to get there.
Okay.
Which is very helpful time-wise. So it also will allow us to get things in situ, in place, with a single mission versus what would have historically taken multiple missions from smaller rockets.
Okay.
Which is nice, because one mission has a lot less complications than multiple missions, a lot less chances of failure. You can bring actually larger parts instead of being in smaller rockets that are limiting the size of the individual components. You can bring a larger component along. So this is a very helpful thing. And then we get into SLS Block 1B Crew, which you'll notice that we go to 8.9 million pounds of thrust.
Yeah, it looks like there's a extra little white section in there.
Right. So we've got an extra bit of thrust there. We've got some additional storage space, I believe, including that white section. So I think that's not necessarily.
It looks like you go from about 8,000 cubic feet to 10,000 cubic feet of
I see that up top there. Yes, your payload goes up, your ability to launch things into orbit goes up, and at the top there, if you're watching on YouTube
tonnage,
here,
it goes from about 27 tons to 38 tons.
Yeah, and that is into to the moon, versus just low Earth orbit or something like that. Then you get to the SLS Block 1B Cargo. Once again, still 8.9 million pounds of thrust, but look at the amount that the volume goes up, because it's no longer just the crew capsule. Now it's a fairing.
Oh, you know what? I'm seeing between the SLS Block 1 Crew and the Block 1B Crew. The Block 1 Crew, it looks like it's just people, right? The Block 1 Cargo is just cargo, but the Block 1B crew is basically
Right.
cargo and crew together.
Right. Lunar rover or whatever you want to put in
Yeah,
there. It's
yeah.
just, Apollo had very similar capabilities.
Right.
Right. And then the Block 2, which these are meant to be iterative over time. Like we're going to increase the capability over time. So eventually we're going to get around to be doing Block 2 crew, which jumps up to 9.5 million pounds of thrust. And notice the cargo capabilities is no different, but how much total tonnage goes up by quite a bit, from 38 to 43 tons. So you've got that more pounds of thrust gets more into orbit at once, which is helpful. And then we also have the SLS Block 2 cargo. Same, once again, 9 million pounds of thrust.
I guess, yeah, my question
Notice, by the way, the fairing is larger. So we've got even more payload volume with the Block 2 cargo versus Block 1 cargo.
Yeah, there's about 50% more, a little more, 80% more, something like that. Not quite double. From the 1B cargo to the Block 2 cargo goes from almost 22,000 cubic feet to 35,000 cubic feet. That's a lot.
Yeah.
That's a lot. And that's going to be a lot more tonnage in too.
Both the SpaceX as well as the Blue Origin New Glenn, so SpaceX Starship and the New Glenn rocket from Blue Origin are smaller actually in total size in some ways, but they actually can produce more thrust and can launch more tonnage into orbit than SLS can. Currently, this is the biggest that's operational. It's been tested, but those are on the way. So we'll see how that plays out over time.
So tell me, what do you think? Why would we go with so many iterations? I mean, I know part of it is you want to have choice, et cetera, but why not just build I see the crew versus the cargo, but why not just build the biggest one? Is it, again, that stepping stone idea where you're learning a lot with Block 1 and then you're tweaking it and making it really good for Block 2?
I think there's some of that. I think there's also, when you're doing something on the scale of this, that if you don't need it, you don't do it. And this is something that I heard, Elon Musk has said about, all of things that he does, which is, the best part that you can get is the one that you can eliminate. Like, I probably butchered what he said, but basically, if a part's not necessary, why is it there?
Yeah.
So I think by keeping everything that's not necessary out of the picture, I think it only simplifies things and makes it more likely for success.
Yeah, no, that does make a lot of sense.
In the end, that's what you want, is success.
Yes.
So I'll just take a moment here to also discuss the engines, which are actually the RS-25 engines that were first used on the space shuttle. And so in an attempt to keep costs lower, they decided to reuse legacy technologies. Now they've also increased the capabilities of the RS-25 engines, and they're going to be able to operate at over 100% of what they were originally designed to do.
Okay, so hold on. Pause there. What does the engine actually do?
What do you mean?
Because, I look at a rocket, and I'm no rocket scientist, but what does it do? Like, it looks like, I'm thinking about the viewer, the listener that, like, doesn't really know what the engine does. Could also be a host. That, it just looks like a whole bunch of tubes around a funnel. Like, what is actually happening in that engine? And why why is that such an important part of it? Like, what does it do? Is it just combining the hydrogen and oxygen and making it burn the right way? Like, what's happening?
Of course, you have to have the right air to fuel ratio, or in this case, a fuel mixture properly determined. But the main gist of it is just you're trying to get matter to get out the back of the spacecraft as quickly as possible.
Yeah.
And
Newton's
you've
third
got
law.
right equal and opposite reactions, and as a result, you got thrust. And so in the case of this particular engine, as I said, it's using the legacy engines from the space shuttle. It's operating on hydrogen and oxygen.
Mhm.
And so we're combining liquid hydrogen and liquid oxygen with, some sparks, and it produces a massive amount of thrust.
Right.
And this particular launch vehicle is going to have 4 of these RS-25 engines on the back of it.
So in other words, it's taking the liquid propellants, putting them in a chamber, sparking it, and regulating that whole process as it goes. Because I would think you only really have to spark it once.
Right. That's the beauty of the liquid propulsion systems, is that you're able to regulate things. You're able to turn it off. Yeah.
Mm-hmm.
You're able to modify how much thrust matters when you're going through a particular part of the atmosphere where you're about to reach max Q, which is effectively the maximum dynamic pressure on the vehicle, where if you were to
most wind resistance you're going to get as you're going up,
which is right around
gaining speed, but the atmosphere's weakening. It's getting less and less dense. But
it also has to do with the speed of sound. So it's like when you're entering that realm of the right around the speed of sound, you're actually catching up with your own vibrations.
Mm-hmm.
And so, if you have things going at full thrust through the sound barrier, through max Q, you're going to end up introducing more stress on the vehicle than is necessary.
Right.
And we don't want that. We want to try to reduce stress on the vehicle if possible. So what they do is they power down the engines a little bit. They're still going to continue to increase their speed because they're losing mass.
Mm-hmm.
That's the interesting part about a rocket, is that you're losing mass as you go up, which means that every bit of thrust that you're putting into it is going to make it accelerate.
Mm-hmm.
So even though you throttle down a little bit, you still accelerate, and you get through max Q. You repower the engines up to 100%, and you continue on your way.
Yeah.
Now, each of these engines by themselves are producing a massive amount of thrust here. So we're talking about around 512 total pounds of thrust. And so that means that the 4 engines working together are producing about 2 million pounds of thrust when they're working at full operation.
I just thought, just thinking about that, I like building model rockets. Right? I enjoy building them. One of my favorite things to do with groups of people. And so you build these things. Sometimes you build a little engine casing and you put it in the bottom of the rocket. And sometimes people forget to glue the engine into the tube. So when the rocket launches, the engine and the tube just goes right up through the top, right? And I'm thinking, each engine is producing how many pounds of thrust?
Over 512,000 pounds of thrust each.
I mean, I'm not a materials scientist by any way, but there's got to be some strong stuff in there. I would think the engines, in some sense, could just fly right through it. That's got to take immense strength, and in a rocket, which you're trying to keep the weight of it low.
Sure.
That's some engineering right there.
Sure. And the other thing to consider here is that these things are operating at high temperatures, which it makes material science even more challenging.
Mm-hmm.
Now, part of the way is it keeps itself cool. The liquid hydrogen and liquid oxygen are cryogenic. They're well below the freezing point of what we would consider to be normal temperatures. They're well into the negative degrees Fahrenheit or Celsius. And the actual liquid fuel is actually pumped through the nozzles in order to cool them before it actually makes it to the combustion chamber where they're ignited, which is something that has been done with rocket engines for a very, very long time. Mm-hmm. And is why they can even operate. If it weren't for that, they would melt.
Yeah.
So that's pretty neat. There's actually a second engine on this, which is not an engine per se, but a booster. And we saw those in our previous slide. So I'm going to go back here. So yeah, as you're seeing it here, this is the SLS Block 1 configuration. So this is the crew version of the spacecraft. And you can see there are 2 solid rocket boosters, one on each side, each of them having 3.6 million pounds of thrust each. So they produce about 75% combined, about 75% of the overall thrust on the spacecraft at launch. And then, as Rob was saying earlier, they will actually come off the spacecraft, as is shown here. And the whole thing's exploded in this diagram, but they come off over the Atlantic as it's taking off. And that does 2 things. First, if they're empty, they're no longer useful.
Yep. Less weight.
Less weight, exactly. Now, these are like the space shuttle's solid rocket boosters. They're actually a legacy from the space shuttle.
Oh, really? So they're like, they were built during the space shuttle time.
These are the same solid rocket boosters as the space shuttle had, with the exception that they've actually added an additional part to them. They actually extended them, made them longer. So they used to be 4 components, now they're 5.
Okay, cool.
So there's extra rocket fuel there. The benefit is they have a huge amount of thrust.
Yeah.
The drawback is they are on or off.
Yeah.
And once they're on, they're on. And that's, one of the main ways that we saw with Challenger that the space shuttle had that Achilles heel.
How did that mess up the Challenger?
So in between each of the segments of the solid rocket
30-second explanation.
in between each of the solid rocket boosters, they have O-rings, and those O-rings at the low temperatures, they get very hard. And during the Challenger mission, when it was launched,
Challenger. Sorry, I was thinking Columbia for a second there.
Yeah.
When
they are launched at cold temperatures, they were brittle and leaked thrust through the side of the rocket booster and caused the Challenger to explode.
And you can't shut that off.
No, there's no way to shut it off.
So once they were going, they were going.
Yep.
Yeah.
Yep. Now, these have not been. Of course, we're trying to mitigate those problems, but they are essentially the same design still. The main difference between this and Space Shuttle is at the very top of the rocket. You'll see it says Launch Abort System. That's the main difference here. With Space Shuttle, there was no way to get out.
Yeah. I was surprised they never actually had an abort system. I would have thought they would have, because they had that in Apollo and Gemini and Mercury.
Easier said than done.
Fair enough. Yeah, because you're in a shuttle as opposed to on the capsule on top of the rocket.
Right. And
I still always thought, like, really, they don't have some sort of abort, but I guess it just wasn't easy enough.
Yeah. And this system has the launch abort system, which is making sure that those astronauts stay out of harm's way. This is not something, though, that with your cargo is going to be lost. I mean, they don't have a launch abort system for the cargo. It's only for the crewed mission.
Right.
But that's the basic crux of it. And in between, you can see there's all sorts of different segments, but we'd have to go into great detail on, because there's different ones for each block.
Right. Yeah.
So,
but yeah, you have your solids on the side to get you going up there. You've got your liquid main tank to keep you going, and then you've got, once that's gone, then you got the other stuff to take you to the moon.